Oh, Buck looks gross.
So big. Okay, so here we go. Have a look. So rational expressions. This is what we're going to look at, and we've already talked about this when we did our review. So everybody close everything up. When we did our review for SBAC, we looked at a little bit of this stuff. It was just pretty briefly though. So we're going to go back and spend a little more time on it. So rational expressions. How do you define a rational expression or a rational function? So a rational function is going to be. This is what a rational function looks like. It's a ratio. Ratio just means fraction, right? So it's a fraction. It's a ratio of two functions, one on top and one on bottom, that are both polynomials. That's it. That's a rational function. So if we want to look at an example then of, and I'm just going to pull up the textbook for section 7.1. So this is the PDF that you will go to, right, and read all about this stuff. This is what it looks like. Okay, we can skip the introductory stuff. Simplifying rational expressions. That's what this section is about. Okay, when we have a polynomial on top and a polynomial on bottom, we want to try to write it in the simplest form. Now let's use as an example of what we're going to do. Let's just leave this for a moment and let's look at what we would do if we had something simpler than polynomials. What if we just had numbers instead? So we just have, instead of a rational function, we just have a ratio, right? A rational number, just a number that can be written as a fraction. So what if we had something like, for example, let's say 36 over 21. What does that simplify to?
6 over 3, which is, hold on. I don't have any idea. 3 times 7 and
12
6 times
over
6.
7. Okay, good. The answer is 12 over 7. Now, what'd you do to get that?
Just divide them both by 3.
Divided top and bottom by 3. Okay. And you guys you do this in your head, which is good. I mean, you're smart. You can do this in your head. But what did you really just do there? Let's break this down.
Simplified it.
So what's the math that kind of sits behind what you just do intuitively, right?
Division.
So if we take the 36 over the 21, let's write each of those in factored form. So let's break them out into products of, we're going to write these in prime factor form. So we're going to write them as products of the smallest factors that we can. So what would the 36 break down into? If we make a factor tree, 6 and 6, okay, and each of the 6's breaks down into 3 and 2 and 3 and 2. So if we wanted, we could write this then, for example, as 2 times 2 times 3 times 3, right? 2 2's and 2 3's. Everybody agree? Those are the prime factors of 36. If we wanted to, we could write that even as 2 squared times 3 squared, right? Either way, it's fine. It doesn't really matter. What about 21? That's a little easier. What are the prime factors of 21? 7 and 3. Right? So then what did we do? Well, all we really did here was we just canceled like factors, because we can do that. When we simplify fractions, we can cancel like factors. We've done that for a long time. So look, I've got a 3 there and a 3 there that I could cancel, right? Or over here I could cancel one of those by crossing out the 2, right? Either way, what do I end up with? 2 times 2 times 3 is 12, and on the bottom, we just get a 7, right? Okay, so there it is with numbers. Now let's look at it with a rational function where we've got polynomials instead of numbers, but it's the same idea. We're going to use the same strategies, right? So we end up with here, let me make this a little bigger for you, how about? Oops. So we've got this rational expression, okay, x squared plus 8x plus 16 over x squared plus 11x plus 28. So just like before, we want to take the numerator and the denominator and we want to write them in factored form. We want to write them as the product of the smallest possible factors. Well, you guys are good at this. We've done a lot of this stuff. These are just quadratic expressions, right? So x squared plus 8x plus 16. What's A? 1. What's B? 8. What's C?
16.
Okay, when A is 1, factoring is simple, isn't it? Right? We always want to see if we can factor out a greatest common factor. But we can't here, can we? Right? We're stuck with, there's no number there and there's no variable there. So there's nothing I can undistribute from the top, right? We're just going to factor it. Well, what are the magic numbers that multiply to C and add to B because A is equal to 1? 4 and 4, right? So we just get, on the top, we would just get x plus 4 times x plus 4, which is the same thing as x plus 4 squared. And on the bottom, we get an x plus 7 and an x plus 4, right?
Get 7 plus 4 is 11, and 4 times 7 is 20.
Right. Right, okay, so easy to factor. What can we cancel there?
The 4s.
The 4s. We can cancel the x plus 4s. Now, we got to be a little careful with that. When we cancel them, it's true that the original function, once we factored it, if we're going to worry about the domain of this function, what are the values of x that we have to exclude? Look at the denominator. Before we cancel anything,
1.
what are the values of x that would make the denominator equal to 0?
Oh,
Negative 4
Negative 4.
or negative 7, right? So we know right away that x cannot equal negative 4 and x cannot equal negative 7. Those have to be excluded, right? Because we started off with an x plus 4 on the bottom. But if we're going to write this in simplified form, we're just going to cancel the x plus 4s, and that ends up being our answer. But one thing you got to remember, and it's not going to show up on this first assignment, but we'll come back to this. The domain still has to exclude that negative 4 because it was originally a 0 of the denominator. Okay? Does that make sense? We'll come back to that. Come back to that later.
Are they all gonna be in so that we can find magic
Yeah,
numbers?
they're going to be stuff you can factor. Exactly. So there's another example here that shows up on your textbook. I'm just going to pull a couple up from Moodle so we can look at a couple, maybe a little harder ones. I gave you some harder ones to do too. Okay, so if you were to go into Moodle at this point, let's see, where are we here? Algebra 2.
I'll give you an
Okay.
equation.
What-
2x plus 12 over 6x squared plus 6.
Oh, how about that? Yeah. But that's a good one, but I think I'll choose my own.
I really need this one done. My last
Uh-huh.
one, it's a 1.
Uh-huh. Yeah. Gotcha.
Okay, it's my first
Gotcha. Oops. There we go. Okay, so let's try something a little harder. How about if we try something
one.
like
5x negative 15 over 3.
like that?
X squared minus 180x plus 270. That's a tough one.
We'll get to some. Yeah.
Mine's just like that.
Yeah.
No, it's not.
Okay, simplify this expression. Let's try a couple of these, and I'm just going to let you do this assignment here in a second.
X can't be negative 4. It's the same question.
It's pretty similar, isn't it? That's just totally random, too. Okay, the top's factored, isn't it? What about the bottom?
Nope.
X plus 4 and x plus 4. Okay, so we could write this as x plus 4 over x plus 4 squared, right? Or x plus 4 times x plus 4. Okay, if we're going to keep track of, and once again, you're not doing that on this assignment, but let's just get in the habit for the next assignments. What are the values of x that I would have to exclude here?
Negative 4.
Negative 4, and that's it, right?
Yep.
X cannot equal negative 4. So in this case, when I cancel like factors, what's going to happen?
Does it just leave you with 1 over x plus 4?
It does, right? Because I'm going to cancel 1 from the top and 1 from the bottom, right? And I just end up with 1 over x plus 4. It might be easier to see it first if we wrote the bottom out, right? So this is the same thing as saying x plus 4 over x plus 4 times, not that x, x plus 4 and just cancel those, right? If I cancel a factor from the top and it's the only factor, then what am I left with instead?
Just one.
Just 1, yeah, right? So either way, I just get 1 over x plus 4, right? Okay, let's try another one. Oh, you know what I want to do?
Some on purpose, keeps me entertained. What number on my computer did I need to switch? You wrote it down on this. Okay.
Okay, what about this one?
You can get rid of the x, 2x squared.
Okay, yeah, so now this kind, remember, this kind is easy, but sometimes people want to make these hard. Why don't you guys close those up? So on the top, what does the top factor into? What can I do with the top? Now, don't make these hard, these are simple, right? What you always want to try to do first is factor out a greatest common factor. Can I undistribute anything? An x, yeah, right? Because the coefficients are both 1, but both terms have an x in them, right? And in fact, what's the biggest power of x that I can undistribute? Just an x. This one's only got an x to the first, right? But if I undistribute an x, what's left behind?
X squared. X plus x.
No,
1.
plus 1, yeah, right? And how do we know? Because we would answer the question,
Oh.
x times what is x squared? Well, x. X times what is x?
X
1, right?
Oh, okay.
Now on the bottom, what can I undistribute?
Both. -9.
No, I can't. There's no number there, right?
Shoot.
So I can't undistribute any number, but I could undistribute an x, yeah. So on the bottom, I'm going to end up with x times,
-9.
Minus 9.
there you go, okay? So real quick, while we're at it here, let's write down our domain. What are the values of x we'd have to exclude?
9.
X cannot equal 9,
Or
and
-1.
x cannot equal,
-1.
no. What's the 0 of that factor?
0.
0, yeah, right? Whenever you have a monomial factor, right, you have it could be, it's some, you might have maybe it's a 3x, doesn't matter. If you have a monomial factor, so it's something times x to a power, not plus or minus something, right? Just that one monomial means just one term in that factor. The 0 is always going to be 0, right? If I set this equal to 0, when is x equal to 0? Duh, when x is 0, right? So those are the two values of x that we have to exclude, right? Now we can simplify. So what crosses out here? What cancels out? X. And so my answer is just x plus 1
-9.
over x minus 9, right?
It's not
Okay.
that tough.
No, it's not bad. Okay, let's try one more.
That's how you write the answer. Like that.
Try, how about, oh, try one of those. That's a good one.
7 times 8. That's your good numbers. So it'd be like x plus 7 and x
Geo,
plus 8.
can you keep it down?
Ready, hold up. I can't do it. I'm sorry.
Keep it going.
Okay, what do we got? Okay, what's the top factor into?
You can do the
What do we got? Well, the magic number's in the top one.
X plus 8.
Yeah, x plus 7, x plus 8, good.
Oh, I said that.
Okay, what about the bottom?
X,
-7, -1.
X plus 8, X minus 1.
No.
Okay. So what are the values of x that we have to exclude?
8.
Can't equal, no, remember, the only thing we have to worry about are the zeros of the bottom, because what's the rule that we're following here? We know we can't divide,
+1.
no, hang on.
Why not?
Just think about, you're right, it is +1, but I wanna know why. No, you got the right answer, but that's not the question I'm asking right now. There's two rules we have
divide
to
by
follow
zero.
for real numbers. We can't take a square root of a negative number, take an even root of a negative number, that doesn't apply here.
Can't
The other
divide
one
by
is we can't divide by
0.
yeah, so we're looking at the zeros at the bottom are the ones we have to exclude. So x cannot equal 1 because that would give us a 0 on the bottom, and
Equal -8.
x cannot equal -8, good. Okay, and then we'll just cancel, yes, sir.
Why is that one was 1 and it's a 1 now, but the other one is 0?
Because it was.
Okay, because the other one, look, on the other one, it was just an x by itself.
So to get it to be 0.
Right, so, no, let's look at this. So look at the denominator here. The zeros of the denominator. Let's take the two factors. We get x minus 9 equals 0 when what happens if I solve for x? What do I get?
Positive.
Okay, what about the other one? We've got, the other factor is x equals 0. What's the solution to that? X equals 0 when?
Wait, but there's no 0 up there. On the left side.
On the left side?
Yeah, on that equation or something.
Oh, on this one or this one?
That one.
That one, yeah. So what are the two factors there? Think about the two factors. I've got an x times an x minus 9,
That's
right? So I've got to set, if I want to find the zeros of the denominator, I'm going to use the zero product property, right? When does x times x minus 9 equal 0? Whenever x equals 0 or whenever x minus 9 equals 0.
I wasn't confused enough.
Yeah, I'm pretty confused now.
Okay. So yeah, now think what we're saying here. We want to know where is it that the bottom could be 0. So let's just focus the zeros of the denominator. Let me start over with this, right? So we want to know any place where, what does that mean? Any place where the bottom is 0, the function's going to explode. It's going to blow up, right? You can't divide by 0. So let's take the bottom and we're just going to set the bottom equal to 0 to find the zeros of the denominator, right? Well, we're going to use the zero product property. Now, I think this is, how many factors are there in the numerator? What does it mean to be a factor? Again, if we go back to our very first page, right there, what are the factors of 36? You told me it was 2 times 2 times 3 times 3, right? So 2 is a factor of 36, and so is 3. How
So
come?
you're distributing the x, and it's 0. If it is 0, then it makes that x 0, and it makes the -9 0, and you cannot divide by 0.
Right, that's right. Now put it in the context of this though. Why is 2 a factor of 36? Because it goes evenly into it, right? It's one of the things that we multiply out to get 36, right? Does that make sense? When I break 36 up into its prime factors, it's just a list of the things that are multiplied. Highlight that word. Factors are things that are multiplied, exactly, right? Factors, that's the really all you got to remember about factors is they are the things that are multiplied. And so if we look at this example, whoops, which one are we doing? This one, right? So what are the factors of the numerator? What are the things that are being multiplied in the numerator? No, 1 is not. 1 is being added to x. 1 is not a factor. X is one of the factors. What's the other factor? X plus 1, right? Because there's two things being multiplied there. I've got x times x plus 1. We call it the quantity x plus 1 because we just have to remember that it's contained in parentheses, right? We treat it as one thing, as one factor, right? What are the factors of the denominator?
X and X minus 9.
x and x minus 9, right? Go back to the zero product property. We know that an expression that is factored, right? Something that is written in factored form is equal to 0 whenever the individual factors equals 0. And remember why that is, because the only way you can multiply stuff and get an answer of 0 is when you do what? If I'm multiplying two numbers to get 0, well, what can you tell me about one of the numbers for sure? It's 0. It has to be, right? The only way you can multiply things and get an answer of 0 is when you're multiplying by 0. So then all we're doing is when we apply the zero product property, and I know this is review, but it's probably good review, is we're just asking ourselves, okay, well, if we're going to get 0 for an answer, what are the values of x that could make that happen? Well, what's the value of x that's going to make that factor equal 0? 9. Yeah, if I set x minus 9 equal to 0 and solve, I get 9, right? X equals 9. If I plug in 9 for x, I'm going to get something times 0, which makes 0. That works. What about the first factor? Well, this one is just so easy that it's almost like tricky in a way. That's the whole factor is x. If I set that equal to 0 and solve, what's the answer? 0. Yeah. So whenever I get a singleton x out there that's not plus or minus anything, the 0 of that factor is always just going to be x equals 0, right? Does that make sense?
Yeah.
Okay. So then what about this guy up here? Now this is different because it's not an x by itself, it's an x minus 1, right? So what's the 0 of that factor? X minus 1 equals 0 when x equals 1. Well, there it is. What's the 0 of this factor? Okay, x plus 8 equals 0 when x equals negative 8. There it is, right? And now we can go ahead and simplify this thing. If I cancel the x plus 8s, what am I left with for my answer?
X plus 7 is
Okay, x plus 7 over x minus 1. How much time do I have?
5 minutes.
5 minutes. Okay, rather than go any further, I just want to show you something cool here. So pay close attention. This is really cool. So in math, let's look at Desmos and let's graph this function. That's beautiful whistling, Trent.
Thank you.
But let's it's very musical, don't you think?
Yeah.
Very musical, but let's hold off on that for a moment here.
Thank you.
Okay, so if I were to graph this function, let's see what we get. If I graph x squared plus 15x plus 56 all divided by x squared plus, there we go, plus 7x minus 8, I get something like that, right? And I'll go ahead and zoom in just a little bit, okay? Yeah, that's good, okay? Okay, so let's just try real quick. Let's try graphing the simplified version of this. Let's graph, and we're going to call this top one f of x. Call it the function f of x, how about? Okay? Now let's do the simplified function. We're going to call it g of x. And that ended up being just x plus 7 over x minus 1. How do you think the graph, what was it, x plus 7?
X minus
Divided by x minus 1? How's the graph going to compare to the red one, do you think, when I put in the minus 1? It's going to be the same. It is. They completely overlap, right? Okay, but they're not exactly the same. Let's go up to the red one, and let's evaluate this function. Let's evaluate the red function at 10. Look what I get. If I evaluate the blue function at 10, same answer, right? Let's evaluate the top one at 1. Oops. Undefined. How come? Well, look up here. That's not included in our function, is it? Right? Okay. Let's evaluate the bottom one at 1. What am I going to get? Should be undefined probably, right?
Yep.
Okay, it is.
Let's do negative
Right.
8.
Okay, let's do negative 8. Yeah, if I do the top one at negative 8, it's undefined, it should be. Yeah, no problem. So bottom one can be undefined?
Nope.
No, it's not, right? So what's the problem there? The bottom one, it does, if I go out to negative 8 on the bottom one, there is a point on that function, right? Because negative 8 is not a 0. Was it negative 8? Yeah, negative 8 is not a 0 of the denominator, right? But it has to be, because we're supposed to be making the same function as the red one, right? If I go to the red one and I try to plug negative 8 in, let's turn this guy off. You can't see it, but there is a hole in the function right there at negative 8. And I can prove it if I graph the line x equals negative 8, and I look for the intersection. Well, it's going to show me that there's a point there just because that's the x-intercept of the line. But there is no intersection between those two curves because there's a hole, and you'll never be able to see it because it's only 1 pixel big, no matter how much I zoom in, right? But we have to include, so the moral of my story is that we have to remember that in the original function, negative 8 was disallowed. It had to be excluded, even though when we write the simplified version, we can write it as a simpler function that has the exact same shape, right? But we still have to retain this information that, nope, there is going to be a 1 pixel hole in the function at negative 8. It doesn't show up here, right? Does that make sense?
No,
Okay.
because
Makes a little bit more sense.
how, if something, you can't, gosh. You know how we like, we cut the
He
door in
doesn't
half, there's no, like you go small.
To the door, you mean?
Yeah.
Yeah.
So how can there not be one of those?
How can there not